This is not the program, it is the introduction. It's a little lengthy, but it's pertinent background information. York is unique in having two major manufacturers of equipment for the hydroelectric industry, the world's largest source of clean, renewable energy. Most are familiar with one of these suppliers, that being Voith Hydro, a member of the worldwide Voith Group and the subject of a presentation to this group by Kara Donlan Cotton just 1 year ago. But not so many are familiar with the second, American Hydro. American Hydro was formed in 1986 at the time of the acquisition of the Hydro Turbine division of Allis-Chalmers. It was a corporation owned by Voith. Four prominent engineers from Allis-Chalmers decided the United States needed to have an American-owned hydro turbine supplier. And in the early 20th century, there was a multitude of American turbine suppliers. But through severe competition and consolidation, that number dwindled to one in the 1970s. And through the Allis-Chalmers Voith acquisition, there were none. They formed American Hydro. And over the next 25 years, they built their enterprise from a small startup engineering company to a $50 million annual business, focused on the upgrade and rehabilitation of existing older hydroelectric units around North America. In 2010, nearing retirement and unable to find a suitable American acquirer of the business, the owners decided to sell to the Weir Group of Scotland. In the prior 15 years, American Hydro and Weir had developed a strong working relationship in which American Hydro provided hydro equipment to Weir for the upgrade of plants in the UK. Weir struggled to find a true home within their portfolio for the type of business that American Hydro performed, and ultimately they sold the business to Wärtsilä Corporation, a large Finnish conglomerate, in 2016. Wärtsilä, realizing its core markets of large reciprocating engines and marine propulsion systems, reviewed its forward strategy and building on its energy services platform is now serving the renewables energy field, with hydro as its basis and looking to service wind, solar, and energy storage systems. American Hydro expects to capitalize on an expanded service area beyond North America and by collaboration with the new companies, sure to join the Wärtsilä fold. Alan Roth, our speaker, has spent his entire 42-year career in the hydroelectric industry, beginning as a hydraulic engineer for Allis-Chalmers, immediately following his graduation from Bucknell with a BS degree in civil engineering. From there he entered the sales and marketing side of the business and rose to VP of Sales and Marketing in 1996 with Voith Hydro. He left Voith in 2003 and spent 8 years with a leading hydro consulting firm in the US. In 2011 he joined American Hydro very shortly after the sale to Weir. He served in 2 previous sales and marketing roles with the company before assuming the presidency in 2015. He recently announced his retirement, and his last day of American Hydro will be July 6th. Alan is married to his wife of 40 years, Mary Ann. He is a father of 2 successful grown daughters and a grandfather for the first time to a little boy born in April. He's looking forward to his grandfathering duties in retirement. It is my pleasure to introduce my very good friend, Alan Roth.
I'm going to try this lavalier versus the podium mic. Can everyone hear me all right? Okay, good. Okay, I've noticed over the years that I've been a Rotarian that most people start their talks with a joke or something. And I'm really not very good at that. So what I decided to do was have a quiz. And you laugh, but I've actually got a list of 20 multiple choice questions that I expect all of you to be able to answer. You thought I was joking. Okay, in all seriousness, this question number 1. You're in a rowboat in a lake. You have a penny in your hand, which you throw overboard, and the penny sinks to the bottom of the lake. Does the water level in the lake, A, rise? Does it fall? Or does it stay the same? I'm going to give you a lot of time to think about that. And we'll actually get to an answer a little bit later. I thought before we talk about American Hydro, we'd talk a little bit about hydropower in general. You know, it's been around for centuries and centuries, not necessarily to generate electricity, but as a mechanical means of power. Since 4th century BC, the Greeks used it for grinding grain, sawing wood, etc. And by the end of the 18th century, there were over 10,000 water wheels just in the northeastern United States. So, and the first hydroelectric plant was developed in the U.S. in the early 1880s, shortly after just the invention of electricity. Hydropower around the world. There are over 11,000 hydropower stations in the world. Almost 1,400 gigawatts. I don't know if you're familiar with the term gigawatt, but if you look at a kilowatt or a watt, and then a kilowatt is 1,000 watts, and a megawatt is 1,000 kilowatts, and a gigawatt is 1,000 megawatts, it's a lot of power, okay? So there are 1,400 gigawatts of power installed around the world, which is the equivalent of 1,700 of the units installed at 3 Mile Island, just to give you an idea of the size. Installed in 160 countries. The leading countries are China, US is second. You can see China has far more than anyone else, and they are continuing to add to their base. USA, we're second, but we're relatively flat in the growth of hydro, and we'll talk about that a little bit. Brazil is third, and Canada right behind. And you can see that there's almost half right there in those 4 countries of all the installed capacity in the world. Some well-known large projects. Many of you may have heard of the large project in China called Three Gorges. That alone generates 18,000 megawatts. It is the largest single construction project in the world that's ever been undertaken. And it was very controversial because it displaced a lot of people, but it has been up and generating reliably now for almost 10 years. Itaipu in Brazil, a very large project on the Paraná River between Brazil and Paraguay. And then Grand Coulee right here in the US with almost 10,000 megawatts, very large plant. I have a professor when I was in university, and he spoke kind of funny, and he always would twirl his finger, and he'd say, you know, and he'd say, Grand Coulee is the biggest block of concrete ever poured. And that was true in the 1930s. It's no longer true as these projects have surpassed that. What are the benefits of hydropower? It is still, by far, the world's leading source of renewable power. Wind is fast growing, certainly, but hydro is certainly the largest. Counts for 35% of renewable energy in the US. Wind, just last year, overtook the hydropower in generation of electricity. But hydro does something that other forms of renewables can't really do, and that is provide support to the electrical grid. These other sources of power, wind, solar, are what they call intermittent or unreliable sources of power. And they need something to back them up when the sun doesn't shine or when the wind doesn't blow. Hydro is excellent at that because it can respond very quickly to demands of power. And there are ways to store energy with hydro. If you have a large dam and you stored a lot of water behind the dam, that is in effect a big battery. And when you need the power, you can release the water from that behind that dam and generate electricity. Also, recreation is huge. I just did a little checking, and I don't know if any of you have heard of the Bass Masters Tournament or the Bass Anglers Association, but I looked, and in 2018 they have 36 tournaments scheduled. 25 of them are behind hydroelectric. They're in hydroelectric dams, or the lakes formed by hydroelectric dams. So I think the bass fishermen are very pleased with hydro. This is just for comparison. I'm going to go through this real quick. I'm not even going to mention it too much. I just want you to look at the efficiencies, the efficiency of generating power. These efficiencies are what's the available power and what do you actually get out of it by doing that source of generation. And you can see solar and wind are relatively low, and thermal power and nuclear are in the 30s or so, but hydro is at 90+%. So it's a very efficient form of generating electricity as well. Okay, this is the results of a study performed by the National Hydropower Association, and they are saying we now have 101 gigawatts. Oh, that wasn't supposed to happen. Oh, there's the answer to the question. There's 101 gigawatts of power, if you look in the center there, installed currently in the US. And there are other ways to increase that. There's a goal of adding 50 gigawatts, by 2050. And doing that by, if you start in the lower right-hand corner, new stream reach. That means where there are no dams or anything astream, you may put a diversion structure in to collect the water and put it through a turbine. Up in the upper right corner, new development of existing non-powered dams. There are 80,000 dams in the US already. Only 3,000 of them have power associated with them. That doesn't mean they're all able to generate power, or certainly economically generate power. But the potential is about 5 additional gigawatts. New pump storage. This is really the means that is used. I've talked about storage and balancing some of the other renewable sources of energy. Right now, I don't remember exactly what's there now, probably right around that 35 gigawatts. And there's an additional 35 yet to be had. And that would be very important to stabilizing our grid as we add more and more wind power and solar power. Batteries themselves, true batteries, are certainly coming along and getting more and more efficient all the time, but this is really what we call utility scale storage. These are 1,000 megawatts in one plant, able to respond to the needs of the system. And then on the far left there, upgrades of existing hydropower facilities. And that's really what American Hydro does. We look at existing plants and try and get more capacity or more efficiency out of them. And that's what I meant to do there. Now, I don't want to get too technical, but I do want you to understand, this helps you to understand what American Hydro does. This is a section through a typical hydro plant. The far left, the blue, is the water behind the dam. It comes down through that, what they call intake structure there, and comes and goes through the turbine and the turbine runner, and then out through what's called the draft tube into the water below the dam. And the water going through the turbine, making the turbine rotate and spinning the generator is what creates the electricity. So what's a hydro upgrade? I mentioned it briefly already. It's, what's really happened. A lot of the plants in that 101 gigawatts were installed in the 50s and the 60s. So those plants are now, pretty old. They're 60, 70 years old. And a lot has happened technology-wise in that time frame. And through particularly what's called computational fluid dynamics. It's a type of analysis of water flow. We can come up with designs that are much more efficient than what was done back in the 60s and the 50s. So replacing the key components, and I'd circled that turbine runner in the previous slide, and those are turbine runners up there. I'm going to try and do this without advancing the slide. These are turbine runners. This is an old one that was actually provided back in the 30s. And this is a new one that American Hydro provided to replace that runner just about 5 years ago. And here, this is just a curve that shows power on the x-axis here and efficiency here. And this just shows that by replacing the runner, you can go from a curve that generates this amount of power at that efficiency level to one that generates more power and more efficiency. So that's the nature of American Hydro's business right there in a nutshell. Okay, answer to question number 1. The water level in the lake will fall. How many got it right? 2. We won't ask you to take any more physics tests. I'm not going to explain it, but it's there if you want to know. It's basically weight versus volume, and because I'm not going to explain it. It takes too much time. It's all there. Okay, American Hydro. This little history here was done by Reverend Stephen Nicholas, who was here I think about 2 years ago, maybe a little less than that. And he went through the history of S. Morgan Smith. And this really all pertains to that same history. First, York has quite a history with hydro. First turbine was manufactured around 1870. S. Morgan Smith was founded here in 1877. Allis-Chalmers purchased S. Morgan Smith in 1959. And then Voith purchased the hydro turbine business of Allis-Chalmers in 1986. And that's when 4 engineers decided that they felt that the United States deserved to have a hydro turbine manufacturer in the U.S., U.S.-owned manufacturer, and that's when American Hydro was formed. These are the 4 gentlemen that formed the company. John Degnan, who unfortunately is now deceased, was head of engineering. Jim Nolt was head of manufacturing. Salim Shakur was the president of the company and really had been instrumental in the development. I talked about this computational fluid dynamics. He developed his own software to do that and was really the basis for the company. And Bill Colwell was the head of the sales and marketing department. This is just a quick history, which I won't spend really any time on. The manufacturing facility that we're in today was built in 1991. The company was formed in '86. 5 years later, they built this manufacturing facility in East York. The Weir Group bought it in 2010, and then Wärtsilä from Finland bought it in 2016. Okay, so we've been around 32 years. We employ about 170 people, and we have 3 shifts of operation in our factory. We have, since the initiation of the company, we've upgraded over 700 turbines. So in the 32 years, you can do the math and figure out how many that is. But believe me, it's a lot. And the thing that's kind of really great about hydro is it's all different. These are 3 different types of hydro runners. On the top, we have what's called a fixed blade propeller. And the bottom right is a Francis runner that's named after a guy named Francis that developed it back in the 1800s. And a Kaplan runner on the left, which is an adjustable pitch runner that has very flexible in its operation. But we build machines that are up to 200 runners that are up to 250 inches in diameter, weigh up to 120 tons, and have generated over 400 megawatts, individual units. So we can do anything up to that size. We also build runners that are 30 inches in diameter, so quite versatile. What do we do? Full service modernization of a hydro unit. And engineering is really key for us. Everything we do is based on our engineering experience and our tools that we have. We build new components, new runners to try to improve the performance of the machine, and other components that may have worn out, and rather than rehabilitate them and just redo them, they get replaced. We do existing component rehabilitation, which is all the other components of the turbine. We rehab those. And then we also do the field work associated with them to take a unit apart, replace the components, put it back together. We also do some new hydro. We don't do a lot of new. If we have a customer that has a particular need and it requires some engineering, we will do that work. We don't just go out and try and sell new units. There are lots of companies that do that frankly we can't compete with. our niche is this upgrade of existing units. So as I said before, driven by engineering, this is really the basis of our company. And the hydraulic design aspect is what we do is we design the shapes of the pieces that touch the water. All the shapes as the water goes through the turbine, primarily the runner. We use this computational fluid dynamics, some of which was developed internally. We also use some commercial software that's out there today. We do proof of our designs sometimes with scale model testing. We'll build a 12, 15-inch model fully to scale of the hydraulic shapes and test it in a laboratory to see what the performance is, and then we can correlate that to our tools that also predict the performance of the machine. We also do mechanical design. There's a lot of, we have to make sure that the thing's going to hold up. You know, it's under a lot of load when it's operating, and we have to be sure it's not going to crack, not going to destroy itself. So we do a lot of mechanical analysis just to ensure that it's going to stay together. And sometimes there's compromise between the hydraulic design and the mechanical design because we may not be able to build the optimum hydraulic design structurally. This is, one thing I want to say about our engineering is this really draws a lot of people to our industry. I already mentioned that there's a lot of diversity in the types of machines that we do, but I can honestly say we have never built the same turbine 2 times, unless there are sister units in a plant. Everyone is different, so it's exciting for the engineers to be able to apply these tools. I call it like gaming design. It's almost, we're designing tools that are very interactive, or we're using tools in our design that are very interactive and very, very interesting for the engineers. We also do what's called systems engineering, where this is stuff we don't manufacture, but is part of a hydro unit, like a generator, the control system for the unit, balance of plant is protection and things for the unit. But these are things we don't build, but our customers demand them of us. So we have to have at least the knowledge to go buy them and ensure that we're protected with what we're buying and that the customer is getting what he wants. On the manufacturing side, okay, our facility on Stonewood Road is 100,000 square feet. We are able to lift 200 tons in that facility. We have a 40-acre campus, and we actually have soccer fields set up that we allow local teams to use. We are dedicated to turbine manufacture. We're not a job shop. We don't do a bunch of different things. We just do hydro. And we have complete fabrication, meaning the bending of the steel, the welding of it, and then machining, which is putting it on big tools to get the dimensions to be exactly right. And all of that is done with computer numerically controlled tools. It's a highly integrated system. For instance, a runner blade, you saw those runners, one of those blades, when we manufacture it, we don't create a drawing. It goes directly from the computer terminal that the engineer has used to design it to a computer terminal at the machine tool, and the work is done without even a drawing. So I just wanted to point out this is also a key aspect of our manufacture. This is a blade that was cut out of plate steel, heated to 1900 degrees Fahrenheit, and then it's put in a former that presses it and makes the shape. The formers are machined very exactly to the design of that shape, and that really is our method, our niche of manufacturing turbine runners. We also have some robotics that we use, and we're looking at more robotics that I'll mention in a minute. But we have total manufacturing support with different other types of engineering. A lean enterprise, I imagine some of you are familiar with that term, which is primarily waste elimination, finding waste in your processes, in your inventories, all types of different wastes. We work primarily with stainless steels, carbon steels, cast iron, and a material called aluminum bronze. But mainly stainless steel is what we work with, and I mentioned the robots already. I'm hoping I can get this to work, but I don't. I think I have to get out of the, I think I got time. I have to get out of
What do you need to do?
this mode. Hopefully it still goes.
Apparently not.
Oh. No, I'm sorry about that.
Just put it back.
Hope you don't mind it a little small. But this is a video of our manufacturing operation. Okay, so that was just intended to give you an idea of the types of operations that we do and the size, some of the sizes of the equipment that we work with, and again, the differences of the equipment that we deal with. Then, we built all the equipment and it's time to put it in the field. We actually go to the sites and we assemble crews, and we have to disassemble the units, put the new equipment in, and reassemble it. Safety is obviously our highest priority. It's more important than anything, but obviously we have to get the work done too. So we have very integrated scheduling and planning, and we can just provide a person to supervise someone else to do the work, or we can do the work ourselves. And there are lots of different things that we get involved with in the field, including the testing of the machines and what we call commissioning, which is making sure it's operational, commercially operational. Okay, what makes us different than our competition? I mean, really, it's how we deal with our customers. And we've heard this over and over again. People like working with American Hydro. We really work hard to create deep customer relationships. And we focus really on safety. I mentioned that before. Quality is critical. On-time delivery is vital. On budget is important to both us and our customers. Again, scheduling gets involved. Integrated scheduling, meaning the manufacturer, the field work, the customers, other contractors on site, all integrated into a schedule. Supply chain, and then providing support after we've delivered the equipment and installed it as well. We are certified. In fact, we just went through a quality audit last week and got certified to the newest standard of these three standards: ISO 9001, ISO 14001, which is environmental and occupational health and safety, OSAS 18001. And also, we take pride in the fact that we are really a family company. We are part of a much larger, we're part of a $5 billion corporation today, but we're 170 people family in East York. And this is just a piece of that. We've got 9 multi-generation families that work for us. Where we've got, in fact, one of them is a father and 2 sons. And it's wonderful to see that family environment, and we really try and nurture that in our business. Social responsibility, you know, the community's done a lot for us, and so we like to give back. And ways we've done it is we have what we call a Casual for a Cause program, where every quarter our employees pick a local charity, and we set a goal of contributions for that charity. And if we reach the goal, the company will match it, and also give all the employees, the executive team will cook a lunch for them. And that's all 4, I mean, that's the office and all 3 shifts. So we do it 4 times over the course of a day or a day and a half. And since in the last 4 years, we've raised over $22,000, contributed over $22,000. So that just speaks to the generosity of our employees as well. We hold blood drives, American Red Cross blood drives on site. We've been involved with Ronald McDonald House with their guest chef program. I mentioned the executives like to cook, so they did that. United Way Day of Action coming up this Friday. We are involved in. We did the Walk a Mile in Her Shoes, which you can see see me and my executive team there with Penn State Lion. And we just get involved with a lot of different local charities, but also the last 2 we get involved with apprenticeship and co-op programs, so that we always have a good base for future employees. York College co-op program, we probably have 50%, if not higher, graduates from York College in our engineering department right now. So what's next? We talked a little bit about Wärtsilä. It's a relatively new acquisition. Wärtsilä wants to grow. Like any other company, they want to grow. We have not done a lot of work internationally. Wärtsilä's got a large network. They want to try and, take our model to other areas of the world. Now, what we would like to see out of that is some of the equipment that needs to be get built in York. But we're not exactly sure how that's going to work out, but the organizations are now being put in place around the world to try and support the growth of hydro for Wärtsilä. And for us in York, our growth is going to come from keeping up with technology. And one of the things that we're looking very seriously at right now is what we call adaptive welding. And that is where robots would actually come in and they trace a joint that needs to be welded, and then they actually do the welding, and they continue this back and forth. And it would be an incredible increase in productivity, in the efficiency of building these machines. People obviously say, well, you know, what happens to the employees that are doing that manually today? They will find jobs running these robots. They will find jobs, you know, involved in different aspects of our business. The workforce will change. It's inevitable. And another is adaptive manufacturing. This is just a picture of a ship propeller. We didn't do this, but this is what we're talking about, taking a runner. And that is actually built up with weld. You've all heard of 3D printers, use 3D printers. This is essentially 3D printing with weld material and building a shape up from nothing, just with weld material. And then you would need some high-speed 5-axis milling in order to take all the roughness out of that welded surface and make it perfectly smooth so that it would be highly efficient. So this is where we're headed in York, is improving the technology that we have right there. And I suspect that, well, don't suspect, it will certainly ensure jobs for our company for years to come. So in closing, you know, we're celebrating 32 years. We do provide products of the highest quality. Again, back to engineering, very creative and always different, always challenging, which our engineers love. We're focused 100% on our customers' success, because if they're successful, we'll be successful. We have direct contact with our customers before projects are even envisioned, while they're being developed, while they're being executed. And you know, we as a service company, we want to be there when they need us, and our entire staff is focused on their customer relationship. So I just want to close by saying, you know, it's been 42 years since I joined this business, and you know, I remember my first day, and I remember my first assignment, and I've had a lot of interesting assignments over the years, but nothing has been as rewarding as leading this company, American Hydro, in the last 3 years. The dedication and the craftsmanship of the people that we have working there is beyond anything I've experienced in my career. And that's why I'm also sure that the company is going to continue to succeed. So thank you very much.